Hi guys, welcome back to my channel. Before we start, please don't forget to hit the subscribe button and the notification bell for more videos. Alright? So in this session, we're going to talk about a new concept about geometry which talks about circles. So the first lesson under circles that we're going to talk about is introduction and central angles of circles. And then for my students, you can read more about this from page 140 to 150 of your books. Let's proceed. So let's define what is circle. Circle is a set of all points that are of the same distance from the given point in a plane. Alright, so that is the general definition. If we have a point in a plane just like what you are seeing here, and then if we're going to form segments from the center or from the point on the plane up to any point, okay, with the same distances, we call it circle. Again, a circle is a set of all points that are of the same distance from the given point in a circle. So that's the general definition. And a circle is a round-shaped figure that has no corners or edges. So it means that it doesn't have any sides and vertices. Okay, so that's the thing. Now, in geometry, a circle can be defined as a closed two-dimensional curve shape. So it means that it has no opening or cut. Okay? Now, let's talk about the different parts of a circle. Let's start first with what we call the center. Center is a point or is the given point of a circle. And a circle is being named by its center. Let's say we are going to name this center as A. So we can say that the center is point A, and if you would like to know the name of this circle, it is what we call now circle A. So the symbol for a circle is this. Okay, circle A. Again, you can use the center as the name of the circle. That's it. Next, we have radius. Radius is a segment from the center to any point on the circle. Let's say we have the name of the center, which is A, and then if you are going to draw from the center up to any point of the circle, let's say we will be naming it as B, you can name this as segment AB. Segment AB is the radius of this circle. And then radius has exact measurement, that's why we are using the segment symbol. Unlike if we're talking about a line, okay, the line is this. A line has no ending, so therefore it has no definite measurement. Okay, so but when we are talking about radius, it has definite measurement. Okay, next we have chord. Chord, a segment whose endpoints both lie on the circle. Again, both lie on the circle. So let's say we have the endpoints of this chord AB. So we can name this as segment AB. Or if you are going to draw, even if it is small like this, for as long as the endpoints are on the circle CD, we can call this as segment CD. Again, a chord, it is a segment whose endpoints both lie on the circle. Now, let's have the special type of a chord, diameter. Diameter, it is a chord that passes through the center of the circle. So just like what you are seeing, if this is the center, we have A, and then if we are going to draw a segment that passes through it, let's say this is a perfect segment, so CB or BC. So this one now is segment BC. So segment BC is a chord or the diameter of this circle A. So take note of that. Diameter is also a chord that passes through the center of a circle. So it's the only chord that passes through the center of the circle. Now, let's talk about tangent line. When we say tangent line, it is a line that touches the circle at exactly one point, just like what you are seeing in the illustration. If this is the point A, okay, touches the circle at exactly one point. So you can name a line using a small letter, or if there are 2 points, in this case we can name this either line L or segment line AB rather, okay, or BA. So tangent is the only line that touches the circle at exactly one point. Please remember and take note of that because there are 2 lines that we're going to talk about in a circle. Next, we have circumference. Okay, in elementary days, when we see circumference, it's also the same as the perimeter of the polygon when we are solving all, or we are adding all the sides. In this case, we are solving the distance around, or total distance around the circle. So the formula for this, we have pi d or 2 pi r. So it's like either of the two. So that's the formula for the circumference. Again, when we say circumference, it's just the total distance around a circle. Next, we have arc. Arc is a portion of a curve. So in mathematics, unless otherwise stated, an arc usually refers to the portion of the circle. So this one that you are seeing here is what we call an example of arc. You can name it by its endpoint as well. It has definite measurement. So this one, CD. Okay, so we can rewrite this as arc AB. So this is now the symbol for arc. Arc CD. We also have arc CD. Arc AB or BA or CD tsaka and DC. So that's how you are going to name arc. Okay, so we are now using three symbols. The first, segment or point, then segment, line, and then arc. So these are the usual symbols now that we're going to use in this chapter about circles. Let's proceed. Then secant line. So it's being pronounced as secant. Secant line is a line that passes through the circle at two distinct points. So it's the only line that passes through the circle at exactly 2 points. So we call it secant line. So in this case, our secant is secant AB. Secant AB. Alright? So if you would like to identify it as a chord, it is chord AB. If we're talking about the endpoints. But if we're talking about the line, we call it secant line. Next, we have interior and exterior. When we say interior, the set of all points in a plane of a circle whose distances from the center are less than the length of the radius. So it means it just means that we're talking about the points inside the circle itself. Inside. Okay, when we say exterior of the circle, the set of all points in a plane of a circle whose distances from the center are greater than the length of the radius. So it means we're talking about all the points outside the circle. Interior, all the points inside the circle with measurement of less than the radius. More than the radius, exterior. So in this case, the interior, we have point A, and then the exterior, we have point B. Next, let's answer this. Example 1, part of me. Number 1, let us name the circle. Again, in the definition, we can name a circle using its center. So the name of this circle is circle O. Now, number 2, center. What is the center? The center of the circle is point O. So if you are being asked to identify the center of the circle, it's just the point. Okay? So in this case, it's point O. Now, number 3, radii. Radii is the plural form of radius. Okay? So why radii? Because we're looking for 3 radius here, or radii here. So the first one is segment OA. From the center up to any point of the circle, we have segment OA. So, or AO, there's no problem with that. And then we have segment OB. Then we also have segment OC. These are the radii of the circle. Okay, say segment AO, segment BO, and segment CO. Okay. Next, we have chords. So in this case, we can identify 3 chords. The first one, of course, is the diameter. We have chord BC. We also have chord CD. We also have, the secant can also be identified as chord segment BK. Next, number 5, diameter. Diameter, we only have one diameter, which is BC, because this is the only one that passes through the circle at exactly 1 point. So we have segment BC as the diameter. Next, number 6, secant. Secant, okay, we only have one secant in this illustration or example. We have secant BK because it touches the circle, it passes through the circle at 2 distinct points. Okay, so we have line BK. Next, tangent line. So we only have one tangent line. It touches the circle at exactly 1 point. We have line L. We can name it using the 2 points because we only have 1 point for it. So we can name it using small cursive letter as well. In geometry, that's accepted. Next, number 8, interiors of the circle. We have 3, E, F, G. So we have points E, F, and G. And then exterior, we have 3 points. Okay, points H, I, J. Okay, points H, I, J. Next, Okay, so we have the central angles. The central angles, okay, this is the second part of our lesson for today. Central angle, okay, so the vertex is the center itself. We have three central angles here. We have central angle AOC, central angle AOB, and then we have the central straight angle, angle BOC. So the middle letter is always the vertex, which is the center of the circle. So those are the different parts of a circle. So if you have questions or clarifications, you can chat me or you can comment down. For my students, you can directly message me. You know how to contact me. Next, definition of congruent circles. When we say congruent circles are circles that have the same or congruent radii. So in this case, as you can see, the measurements of the radii, are equal. We have 5 centimeters and 5 centimeters. Therefore, we can say that these two circles are congruent. So we can just look at the radius or the measurements of the radii for us to identify if the circles are congruent or not. In this case, measurement of segment OA is equal to the measurement of segment OB equals 5 centimeters. Now, concentric circles are coplanar circles having the same center. So just like what you are seeing here, the circles are coinciding because they have the same center, which is point O. Okay? So circle O with radius segment OA and circle O with radius segment OB on the right or above are concentric circles because they have the same center. Alright? Next, let's have the second part, central angles. But before that, let's define what is a central angle. Central angle is an angle whose vertex is the same, is the center of the circle. So just like what you are seeing, angle AOB is what we call the central angle because as you can see, the vertex is the center of the circle. Angle AOB is the central angle of circle O with arc AB as its intercepted arc. So this is the central angle and the corresponding arc is what we call intercepted arc. So the degree measure of the circle is 360 degrees. So don't forget that when we are talking about the degree measure of the circle, and if someone asks you if what is the degree measure of the circle, you can say it's 360 degrees. One revolution is 360 degrees. Now, that is the central angle. The vertex is as simple as that, the vertex is the center of the circle. Next, central angles, examples of central angles, the illustrations show examples of central angles. So if the central angle is 100 degrees, we can also say that the intercepted arc is 100 degrees as well. Don't forget that. The central angle and its intercepted arcs are always equal. And here we have 90 degrees, the violet illustration. The arc also measures 90 degrees. And then for the green, 180 degrees, the arc also measures 180 degrees. So those are the things that you need to remember about central angles. The angle or the central angle is always congruent to its intercepted arc and vice versa. Okay, when you are solving, they are always equal. Now, before we proceed in solving, let's have the different types of arc. So we have minor arc, major, and then semicircle. Now, what is a minor arc? Minor arc, just like what you are seeing in the illustration, minor arc MI or arc MI consists of points M and I and all points of the circle O that are in the interior of the circle MOI. So just like what you are seeing, this is the minor arc. And you are naming minor arc using two letters. You can name a minor arc using two letters only. Okay? So the degree measure of the minor arc MI is equal to the degree measure of its intercepted arc. Okay? Whatever is the measurement of this is also the measurement of the minor arc. Or in simple manner, it's less than the half of the circle because it's less than 180 degrees but more than 0 degree. So the measurement of it is less than 180 degrees and it's more than 0 degree. Okay? So less than 180, more than 0 degree. Now, let's have the major arc. For major arc, guys, you have to remember that you have to name this one using 3 letters unlike a minor. Okay, so major arc MNI in the illustration, this is the major arc that we are pertaining here. So major arc MNI or arc MNI consists of points MNI and all points of circle O that are in the exterior of the central angle MOI. So the degree measure of the major arc, so if you're looking for this, you can just subtract this 360 from this minor arc to get the major arc. So MNI is equal to 360 degrees minus the degree measure of the central angle MOI. Or to better understand if what is the measurement of a major arc, it is always less than 360 degrees but more than 180 degrees. So it means, guys, it's more than the measurement of the half of the circle. Again, it's less than 360 degrees but more than 180 degrees. Okay, that's for major arc. Next, we have semicircles. For the semicircles DIM and DAM, what is a semicircle? It's the half of the circle. That's why the measurement of this is always equal to 180 degrees. Okay, please don't forget that. We have two semicircles here, DIM and DAM, and you can also name this one using three letters. Minor arc, two letters, less than 180, more than 0. Then major arc, 3 letters, more than 180, less than 360. Semicircle, 3 letters in naming it, and then the measurement is exactly 180 degrees, just like what you are seeing in the illustration here. Now, postulate versus theorem. In geometry, we are always using postulates and theorems. But how are we going to differentiate them? When we say postulate, it's already accepted as universal facts, a statement that is accepted as true without proof. So you don't need to prove this one because it's already accepted as fact. We don't need to prove. Next, theorem. It is an important statement that must be proved before it can be accepted. So we're not saying it's false or what, but the thing is a theorem must be proven first before we accept it. Okay, unlike a postulate, we can directly use it without even proving it because it is universally accepted as fact. Next, postulate number 22. This is the basis in solving for central angle. Postulate 22, the central angle intercepted arc postulate, or the CAIA postulate. Okay? So the measure of the central angle of a circle is always equal to the measure of its intercepted arc. So therefore, whatever is the measurement of this, it is equal to the measurement of its intercepted arc. If this is 30 degrees, this is also 30 degrees, and vice versa. So we can now say that the measurement of angle AOB is equal to the measurement of arc AB. Please don't forget that. Next, example 2. Identify the following minor arcs before we proceed in solving. Let's identify the following minor arcs. So let's identify the minor arcs. Again, the qualifications of a minor arc, 2 letters for naming it, and then the measurement must be less than 180 and more than 0. So first we have segment arc LO, we have arc OD, we have arc DI, we have 4, and then we have arc AIL. So these are the 4 minor arcs. Okay. Now, semicircle measurement is exactly 180 degrees, and we are naming it using 3 letters. Okay, so it's the half of the circle. So the first one is arc LOD. Okay, this one, and then we have arc ODI. We also have arc DIL. And then lastly, we have arc ILO. So these are the 4 semicircles in this diagram. Next, letter C, major arcs containing point L. So major arcs, more than 180, it means more than the half of the circle and less than 360 degrees. So the first one is we have LOI, arc LOI. We also have arc LDI, LOI, and then LDI. We also have ODL. We also have OIL. And then we have DIO. We also have DLO. And then we have ILD. We also have IOD. Okay, so these are the major arcs in this specific diagram. Okay, next, example number 3. Okay, so let's now apply the CAIA postulate, or postulate number 22, the central angle intercepted arc postulate. Now, given the measurement, in letter A, we have given the measurement of POQ, or angle POQ, which is 50 degrees. Identify what's the measurement of PQ. Now, in this case, to better understand, or to easily solve, you have to label it with the given. Okay, so the measurement is angle POQ, label it 50 degrees. Applying the CAIA postulate, we are solving for arc PQ, therefore this is also 50 degrees. Hope you can follow. And then letter B, given the measurement of RS, which is 80 degrees, find the measurement of angle ROS, this one. So CAIA postulate says that they are congruent. So therefore, this also measures 80 degrees. Next, given the measurement of angle TOU, which is 120 degrees, so label it TOU is 120 degrees. This is also 120 degrees. Find the measurement of arc TVU. So to solve for it, okay, so remember that the degree measure of the circle is 360, and then subtract it to the given minor arc, which is 120 degrees. So the measurement of arc TVU is 240 degrees. Okay, that's it. Now let's go to the challenging example. Example 4. Refer to the figure below and the given information to complete the table. If the measurement of angle CER, this one is 60 degrees, and the measurement of angle CEI is 30 degrees, okay, find the indicated measures. First, we are looking for arc CI. So arc CI is this, and the central angle is 30 degrees. Therefore, we can say that this is also 30 degrees. No need to solve, just look at the diagram. Letter B, the measurement of angle IER is also equal to its intercepted arc, which is the measurement of IR, arc IR. So IER is this, and then this is IR. Okay, to solve for this one, just simply subtract 60 and 30. Okay, so 60 degrees minus 30 degrees is simply 30 degrees. So therefore, this is also 30 degrees, this is also 30 degrees. You have to label whatever you are able to solve. Okay, next, arc CR. So where is arc CR? This whole. How are we going to solve this whole? Just combine the two. So 30 degrees plus 30 degrees, or simply 60 degrees, is the measurement of arc CR. Next, letter D, arc CLI. Where's arc CLI? CLI. So this one, arc CLI. Okay, until here. So as you can see, this portion CI is not included. So therefore, we can say that to solve for that, you have to subtract 360 degrees minus the one that's not included, which is 30 degrees. The answer here is 330 degrees. So therefore, the measurement of arc CLI is 330 degrees. Next, letter E. Measurement of angle REL is also equal to the measurement of arc RL. So where is REL? REL. So REL is this. Just remember that the half of the circle measures 180 degrees. So we can just subtract 180 degrees, this one, minus the portion which is not included in the angle, which is 30 degrees. So it's now 180 degrees minus 30 degrees. So the measurement of angle REL and arc RL is 150 degrees. Next, let R 150 degrees. Now, let's have letter F. Arc LCR. Where's arc LCR? LCR. So this one, LCR. Okay, it's more than the half. It's more than 180 degrees. So therefore, add 180 degrees and the portion which is included, which is 30 degrees. So therefore, the answer here is 210 degrees. Okay, so that's how you will find. Just remember, whatever is the given measurements, just put them in the diagram for you to be able to for you to have a guide, no, on how you can actually solve for the unknown measurements. Now let's proceed. Postulate number 23, the arc addition postulate. So the measure of the arc of two adjacent arcs is the measure of the arc formed by two adjacent arcs is the sum of the measures of two arcs. When we say adjacent, they are beside each other. So if you are solving for the measurement of arc AB, you can just add arc AB and BC. That is arc addition postulate. So in the equation, we can say that to find for the measurement of arc AC, it is equal to the measurement of arc AB plus arc BC. So that's how you will solve for it. Now, postulate 24, the diameter divides the circle into two semicircle. So if we are going to draw the diameter which passes through the center of the circle, we can form two semicircles which measure 180 degrees. Now, let us solve this one using postulate 23. Okay, so first we have the given measurement of arc AB is 52 degrees. So we have to put it here, and the measurement of arc BC is 148 degrees. Okay, first we are solving for measurement of arc ABC. So to solve for that, just simply add the 2, 52 degrees plus 140. So we have 52 degrees plus 148 degrees. So the answer here is 200 degrees. So the measurement of this is 200 degrees. Now, we have ADC, arc ADC. This one is the one that we're looking for. Since we already have 200 degrees, okay, just simply subtract 200 degrees from 360 degrees. So the answer here is 160 degrees. So the measurement of this is 160 degrees. As simple as that. You can easily apply the postulate 22, postulate 23 here, and the postulate 24 here. 23 and 24 here. Now, let's proceed. Theorem 96, this is the last one that we're going to talk about for today. The length of an arc of a circle is the product of the ratio. In the examples a while back, we are just getting the degree measure of the arc, but this time we're going to get the length of the arc. So the formula, the product of the ratio of measure of the arc over 360 degrees and the circumference of a circle. So, the length of an arc AB is arc AB equals the measurement of arc, or the degree measure of arc AB over 360 degrees times 2 pi r. So that's the formula that we are going to use. Okay, so we need the measurement of the arc and the radius in solving. So those are the two measurements that we need. Now, let's answer the following. Find the length of each indicated arc and express your answer in terms of pi. So let's start first with the measurement of arc MY. So the degree measure of arc MY is 60 degrees because the central angle is 60 degrees. So substitute 60 degrees over 360 degrees times the circumference 2 pi and the radius, which is 18 centimeters. Okay, first, if you have your calculator, simplify first the fraction 60 degrees over 360 degrees. So the GCF here is 60 degrees. Divide both by 60 degrees. This is 1, this is 6. So it's 1 over 6 times 2 times 18 is 36 pi. And then multiply 36 times 1 divided by 6 is 6 pi centimeters. That is the arc length of arc MY. Now, let's have letter B. Measurement of arc AC. So, measurement of arc AC equals the degree measure. If we have this symbol, the arc AC measures also 90 degrees. So, 90 degrees over 360 degrees times 2 pi times the radius, which is 12 centimeters. Next, simplify this. 190 over 360. The GCF is 90. Divide both sides by 90. So this will become 1. This will become 4. Then 2 times 12 is 24. 24 pi. And then multiply 24 times 1 over 4 is 6 pi as well, centimeters. So that's how you solve. Okay? Just simply follow the formula. Then, let's talk about find the measurement of arc APB. Measurement of arc APB is 210 degrees over 360 degrees equals times 2 pi times the radius, which is 30 centimeters. Okay? Now, so the GCF is 30. 210 divided by 30 is 7, and then this is 12. Okay, then 2 times 30 is 60. So we have 7 over 12 times 60 pi. Then just simply multiply 7 times 60 divided by 12. The final answer is 35 pi centimeters. That is the arc length of arc APB. So that's how you apply theorem 96 in solving for the arc length. Okay, so please don't forget the different postulates and theorem that we have discussed for today about the introduction of circles and the central angles, okay, because we are going to use them as well in the future lessons about circles. Next, problem solving. The circle below shows the typical students from Geom Institute spend their school days. What is the measure of the central angle used for the slip part? So we are looking for the degree measure of this, not the arc length but the degree measure. So for the slip part, as you can see, it's 31%. Okay, to get the degree measure, you need to multiply 31% by 360 degrees. But before that, convert this to decimal, 0.31 times 360 degrees. Okay, calculate it. 0.31 times 360 degrees, you have to convert the percent, you have to move two decimal places from the right going to the left. So 0.31 times 360 degrees is 111.6 degrees. So that is the degree measure of the slip part, which is our favorite in our lives. Okay, the slip. Now, hope that you have learned a lot from our lesson or math concept for today. And then for my students, please answer this activity on your books. Okay, so hope you have learned. And then please don't forget to hit the subscribe button and the notification bell for more videos. Have a nice day, everyone.